Hello everyone. So in today's lecture we'll do basics of elementary particles, or you can say particle physics. So basics of particle physics relates with the four types of interactions. We all know the basic four types of interactions are G1, gravitational, first, second, weak, third, electromagnetic, and fourth is nuclear, which we also known as strong forces. And these four forces are responsible for the phenomena that are happening around. So we can remember these four forces by the mnemonic G1. Okay, and the interacting particles that are responsible for these interactions or these four basic forces are gravitons for gravitational forces, leptons for weak forces, photons for electromagnetic forces, and hadrons or gluons for nuclear or strong forces. Particles responsible for gravitational and electromagnetic forces, which are gravitons and photons, are not further divided, or can say cannot be further divided. And the weak and strong forces, the particles responsible for these two forces, can be further divided. Like leptons can be further divided into different parts or different types, and hadrons or gluons as well can also be divided into subparts, and what we call these subparts we'll discuss further. Firstly, we'll talk about hadrons, which are responsible for strong or nuclear forces, and these particles, which we known as hadrons, are further divided into mesons and baryons. Mesons are also known as bosons, just because mesons are having integral spin, and fermions are having half integral spins. Okay, so the statistics that are involved with integral and half integral spin is FD and BE. Okay, so I hope this is clear to you, because this is the basic like ABC of particle physics, and all these terms should be on your fingertips if you want to score good in particle physics. In last master cadre exam we have seen 3 questions from particle physics. Okay, so I hope you are able to learn or understand these things, these basic particles or their differentiation. So baryons are further subdivided into two types. One is nucleons, and we all know that nucleons are proton and neutrons, and another type is hyperons, and we also know the four types of hyperons. Actually there are five, but we'll talk about four in this lecture, and the fifth one we'll talk in next lecture. We'll talk about in next lecture. Okay, so the four basic hyperons are lambda, sigma, xi, and omega. And lambda is singlet, exists in singlet state, whereas sigma exists in triplet state, and xi in doublet, whereas omega also exists in singlet state. And if we'll talk about baryon number, as we are talking about baryons, so this is a type of quantum number, intrinsic quantum number, and it exists only for baryons. So for baryons it will be 1, and for mesons it will be 0. Okay, so as I've already written here that this is a basic ABC of particle physics, you should learn it, or it should be by heart to you. And if we'll talk about mesons, which are type of bosons, so mesons are of three types. First is k mesons, pi mesons, and eta mesons. K mesons are also known as kaons, and k mesons are further divided into three types. Pi mesons are known as pions, and it is also divided into three types. And eta meson is simply known as eta meson, and it is exists by its own, or can say alone. So k mesons are divided into k positive, k negative, and k naught, and similarly pi mesons are divided into pi positive, pi negative, and pi naught. Kaons and pions have their antiparticles, whereas eta meson is antiparticle of itself. And if we'll talk about the topic or the question that show up in the previous master cadre exam was of tenfold symmetry. Actually, it is of MSc physics, or can say particle physics, that show up in MSc. So we'll only talk about few things about this in today's lecture, and we'll talk about it in detail in next lecture. Basically, lambda, sigma and xi are exist, as I've already mentioned, in singlet, doublet and triplet. And in this the diagram that was there in the exam, a triangle, inverted triangle. So at the top of the inverted triangle there is one, I'll say, type of particles which we are not going to talk in this lecture, that is delta. And on the second tire there exist 3 points, and there is 3 sigma particles, sigma positive, sigma negative and sigma naught. And on the second last tire there is 2 places for xi naught and xi negative, and on the lowermost part there is, so actually it is like a distribution on the basis of isospin and y, which is hypercharge. So by looking at this diagram you can easily understand, or you can easily differentiate between hypercharge and isospin of different particles that are in this particular diagram. So we'll talk about it next lecture. Okay, so the next, if we'll talk about mesons. So mesons are made up of quark and antiquark. Basically, if you'll understand the basic, or can say what it is made up of, you can easily understand the intrinsic quantum numbers, which are going to discuss in next lectures. Because quarks are responsible for basic like intrinsic quantum numbers, which are lepton number, baryon number and hypercharge, isospin. So these are the intrinsic quantum number, and these are solely interlinked with the quarks. Baryon number, or can say baryons, are made up of 3 quarks. Quarks can be different or same, it doesn't matter, because some baryons are made up of all the same quarks like omega SSS, and some baryons are made up of different quarks like proton made up of UUD, 2 same quark, 1 different quark. And if we'll talk about neutron, it is made up of UDD, again similarity. So if we'll talk about just surface knowledge about quarks, so there are 3 sets, or can say 6 quarks, 3 sets of 2 quarks. One is up, down, top, bottom, charm and strange. So the question that I've seen in the meritorious, I think, question paper, they asked about the heaviest quark among all, or it was top quark. And if we'll talk about the example of mesons, then K positive is one of the quarks, or can say kaons, and its quark content is U S bar. U is up quark and S bar is anti quark of S, which is strange quark. Okay, so as I've already mentioned, it is made up of 1 quark and 1 anti-quark, so it like can say justifies the quark content of K positive, and it was also seen in the previous year question paper. I don't know which question paper, but I've seen this question. Okay, so in today's lecture we are only going to discuss about leptons and hadrons and their subdivisions. Okay, so hadrons are, so we have talked about hadrons, and now we are going to talk about leptons, which are responsible for weak forces. So leptons are divided into 4 types. First is electron, then muon, then tauon, are also known as tau, and there are neutrinos as well. So neutrinos are further divided into 3 types: electron neutrino, muon neutrino and tau neutrino, and their antiparticles also exist. Okay, so if we'll talk about the important, or can say important points that can be highlighted, so we can say the heaviest lepton among all is tau, and its rest mass is 1784.2 mega electron volt. And if we'll talk about heaviest meson, and it is eta meson, and heaviest baryon is omega. So this is surface division, or can say basic division of leptons and hadrons, and there are lots of other aspects on which we can talk, and we'll talk about all the aspects in next lectures. And we are not need to hurry right now. Just do your homework, just make yourself prepared about these topics that we are doing daily. So I hope that you're getting my point, that the topics that you learn without any stress or without any hurry for the exam, or without any hurry to complete this syllabus, are going to store in your core memory. And if you are just doing any topic or syllabus after you have seen the date sheet or the deadline for the exam, those topics are not going to last long in your memory. So just make sure that you are doing few topics daily, and you are revising those topics every day, so that they are like stored in your core memory. Thank you very much.